Hello, this is Tony Hiller from visitech.ai. In this video, we're going to do a detailed analysis of the Western water crisis. And I'm going to show you how easy it is to do this using our website, visitech.ai. This is a photograph of the Central Arizona project, which brings water from the Colorado River into Phoenix and Tucson. There's a lot of concern that there's not going to be enough water in the not-too-distant future. A combination of drought and a long history of water overuse is causing the problem. We're going to look at these in detail in the next few minutes. This is a Google Earth image of North Phoenix. On the right is the Phoenix Sonoran Preserve, where I used to take my dogs hiking. This line is the Central Arizona Project Canal. And up here is Taiwan Semiconductor's Arizona Fab. The fabs require huge amounts of water, and they're planning on greatly expanding them over the next few years. They're currently using almost 5 million gallons of water per day, which is about 3% of the city of Phoenix's current daily water use. Lake Powell is the key to Arizona water and has been rapidly shrinking over the last 25 years. In 1989, I used to go cliff diving at the Height Overlook. But the lake is drying up, and now the lake is a long ways away from the same cliffs. The Google Earth imagery from 1989 isn't very good, but you can see what was going on. So let's get into an analysis of this data using visitech.ai. This is what the website looks like for subscribers. The first thing we're going to do is look at Colorado droughts to see how that's affecting the Colorado River. I'm going to select from Datasets, Weather and Climate, and then we'll go down to Drought. Now we have a graph of the NOAA drought data for all 50 states going back to 1895. The state I'm interested in right now is Colorado, so I'm going to select that from this drop-down. To interpret this data, higher numbers are wetter and lower numbers are drier. As you can see, Colorado's worst drought occurred in the year 2002. Now I'm going to press the E key on the keyboard to bring up a map. On the right side, you can now see a NOAA map of the drought of July 2002. You can see that there was a very severe drought over almost the entire West, as well as much of the East Coast. In order to visualize the data more clearly, I'm going to change this from a line chart to a bar chart. On this graph, blue is drought and red is wet periods. The 1980s and 1990s were very wet in Colorado, but since the year 2000, Colorado has been in drought most of the time. I used to go cliff diving at Lake Powell in the 1980s when it was very wet, but 25 years of drought have largely dried up the lake. A lot of people moved to the southwestern U.S. during the 1980s and 1990s when it was very wet, and they developed unrealistic expectations of how much water they could expect to see. Now let's take a look at what's going on at Lake Powell. The first thing I'm going to do is reset the web page so that we're not mixing different types of data together. Now I'm going to go to Datasets, Weather and Climate, and select the Lake Powell data. This opened up another tab which will allow us to select the datasets we're interested in. The data at lakepowellwaterdata.com is extremely useful, but in the format they presented, it's a little bit difficult to extract the important information. The table I want to look at first is down here. It's Table 5. This table shows water levels over the past 2 weeks. I'm going to click on Copy CSV, which will copy that table to the clipboard. Now I'm going to go back to the Visitech tab. Next, I'm going to paste the data by pressing Ctrl-V on the keyboard. If we click on the Table tab, we can see the data which we just imported. The columns we're mainly interested in are date measured, elevation, content, inflow, and outflow. Let's go back to the Chat tab and start doing some analysis. I'm going to click on the Suggestions button to get some selected queries. Let's try some simple ones like elevation versus date. Now we have a graph showing how the elevation of Lake Powell has changed over the last 2 weeks. You can see that the lake elevation has dropped almost 2 feet over the past 2 weeks. In order to measure this more precisely, I'm going to put a trend line on it. Now you can see down here that the lake is dropping at nearly 50 feet per year. Let's ask how many more days it will be until the lake level is too low to generate hydroelectric power. I'm going to click on this question, how many days until Lake Powell minimum operating pool, and then send. The answer is that at the current rate of decline, in 310 days, Lake Powell will no longer be able to generate electricity because the water level is too low. It probably won't be that soon because when spring melt occurs, the rate of decline will slow down. Next, let's find out how many days until Lake Powell dead pool. That's the lowest elevation at which water can flow out of the dam. For the past 25 years, Phoenix, Las Vegas, and other cities have been operating on water which was stored up during the 1980s and 1990s. But once the lake reaches dead pool, they can no longer use water which was stored up during the 1980s and 1990s. So let's find out how many days until Lake Powell dead pool. And there's our answer. At the current rate of decline, it's 1,185 days. There are 3 reasons why Lake Powell water level is declining. One is evaporation, another one is water which seeps into the ground, but the most important one is that water is flowing out of the lake faster than it's flowing in. So let's find out the ratio of outflows to inflows versus the date. We're no longer interested in the elevation, we just want to look at the outflow to inflow ratio. So I'm going to X out the elevation. I don't want to see the purple trend line, so I'm going to get rid of that. And I'm going to reset the zoom so that we can actually see the data. We can see that water is flowing out of the dam almost twice as fast as it's flowing in. And that's the main reason why the lake is declining at a current rate of 50 feet per year. Next, let's take a look at how declining lake levels are affecting recreation. I already discussed how declining lake levels have affected cliff diving. Now let's look at boating. Let's go back to the Lake Powell Water Data tab. The boating data is at the bottom, so I'm going to scroll down there. Next, I'm going to click on Copy CSV, go back to the app, and paste the data in using Control-V. Let's go to the Table tab and see what the data looks like. I'm going to resize this so that we can see the data a little bit more clearly. The columns we're interested in is the name of the marina, the minimum safe elevation, and the minimum usable elevation. Now we're going to go to the Options tab and graph them. For the x-axis selection, I'm going to use the site name, and for the y-axis, I'm going to do current level versus NPS minimum safe, and then I'm going to click on Draw. Now you can see what's going on. The lake level is too low at most of the marinas for boats to launch there, and there's only 2 marinas remaining which are above the safe level. The Bullfrog Marina is only 3.45 feet above the minimum safe level, and remember that the lake is declining about 1 foot per week, so they probably have less than a month left. The State Line Marina is 12.45 feet above minimum safe level, and a rate of decline of 1 foot per week, they have about 3 months left. The key to what happens this summer is snow in the mountains, particularly in Colorado. So let's take a look at that now. Let's select from our datasets Data, Weather, and U.S. Snow Water Content. This brings up the official government snow data, which is updated at least once per day. These red dots show places where snowpack is less than 50% of average. You can see that snowpack is very low across much of the West. Let's zoom in on Colorado, particularly southwest Colorado. Wolf Creek Pass is an important location because it's right on the Continental Divide. Water flowing to the west goes into the Colorado River, and water flowing to the east goes into the Rio Grande. It's also normally the snowiest ski area in Colorado because they get a lot of moisture coming up from the southwest. Let's click on this dot to get a graph. The black line shows how low the snowpack is this year compared to other years. Let's click on the graph to get a larger view. You can see that over the last couple days there's been some improvement, but the snowpack is still way below normal. Let's take a closer look using visitech. We're going to click on the CSV tab to download the data. Now we're going to go back to the visitech tab and drag in the data which we just downloaded. Now we have data for every year going back to 1979. And if we hover over 1979, we can see that snowpack levels were very high that year. Let's widen the graphing window up so that we can see it better. Now let's hover over the current year, 2026. You can see on the red line that snowpack this year is very low on day 50 of 2026. Let's find out what the average is for each day since 1979. I'm going to click on Operation Daily Average. Now the red line shows the daily average since 1979. I'm only interested in the average in 2026, so I'm going to scroll down here to 2026 and click on that. Now the purple line shows 2026 and the red line shows the average. You can see that the current snowpack is about half of normal for the date. There's been a lot of snow the last few days, but they're very far behind right now. Normally the snowpack at Wolf Creek Pass peaks around day 100 of the year. Let's take a look next at how fast the snowpack changes on average on each day of the year. I'm going to X out 2026 because I only want to look at the average data right now. To find out the day-to-day change, I'm going to click on Operation Delta. I don't want to see the average anymore, so I'm going to X that out and then hit Reset Zoom. Now we can see that on average, day 50 is the snowiest day of the year at Wolf Creek, Colorado, which happens to be today. They're getting a lot of snow right now at Wolf Creek, Colorado, but they always do this time of year, so they're not really catching up. Let's plot this as a bar chart now. You can see that for the first 100 days of the year, Wolf Creek Pass typically gains snow, and after day 100, as we go into summer, the snowpack declines. If Wolf Creek Pass is going to catch up to normal, they're going to have a lot of snow for the next 50 days. I'm a data analyst, not a weather forecaster, so I'm not going to make any predictions. Now let's go back to the map and look at a different part of Colorado. Let's take a look at Echo Lake west of Denver. You can see that snowpack there is close to the lowest on record. The larger graph shows that it is the lowest on record. Let's download the data by clicking on CSV. Now we'll go back to the visitech tab and drag the data we just downloaded into the app. Let's scroll down to 2026 and highlight it. You can see how low the snowpack is at Echo Lake. They're going to have to catch up a lot in order to get back to normal. We're going to look at one more location west of Cheyenne, Wyoming, where I live. This is where our water supply comes from. Let's click on the graph to make it larger. You can see that the snowpack here is the lowest on record, and there's almost no snowpack. If this doesn't change, we're not going to have any water here in Cheyenne this summer. Now let's go back to visitech and look at the Cheyenne snow data. I'm going to select from the drop-down menu, Wyoming. Now I'm going to select Cheyenne. Now I'm going to select Snow. Now we have a graph of every snow event in Cheyenne, Wyoming going back to the year 1915. We had our record snowfall on March 14, 2021, when we had almost 23 inches of snow. Hopefully we'll get a repeat of something like that this March. The total storm accumulation was about 3 feet. Curie was very impressed. Let's do some more analysis on this data to see how bad this winter has been. I'm going to click on Suggestions. I want to find out how much snow has fallen during each winter, so I'm going to click on For each December to February, calculate the total. Now we have a graph of the total snowfall for each winter. You can see that this year so far has been the lowest on record. We had a couple inches of snow last night, which probably brings us up to here, but it's still the worst winter on record for snow. Let's sum everything up. Lake Powell is going dry, and there's very little snowpack in the upper Colorado River Basin up above Lake Powell. And to make matters worse, there's almost no snow east of the Continental Divide, which means that Denver and the Front Range will be taking a lot of water out of the Colorado River through tunnels, which additionally puts stress on Lake Powell. Unless the weather changes dramatically, there's going to be water wars in the West this summer. Over the past 15 minutes, we did a very detailed analysis of the water situation in the West. And if you followed the steps I showed you, you could repeat this analysis for any location you're interested in using visitech.ai. By any other means, doing this analysis would have been very difficult, but using Visitech, it was simple. And Visitech works with just about any type of data. You could do business analysis, crime analysis, stock market analysis, real estate analysis, or whatever it happens to be that you're interested in. I'll be making some shorter videos in the next few days illustrating how you can use Visitech for those types of data. If you like this video, please subscribe to my channel, and more importantly, subscribe to visitech.ai.